Hey guys, we are going to talk about page 2 in the 10.3 notes. This is going to be an application of our periodic functions. So let's take a look at what we're given here. Given below is the table that gives the populations of foxes and rabbits in a national park, pretty sure that's supposed to say park, over a 12-month period. Note that each value of t corresponds to the beginning of the month and t equals 0 corresponds to the beginning of January. Alright, so let's just take a look here at our data. So we are going to be talking about rabbits and foxes and their population within this national park. So right now let's focus in right here on the rabbits. So take a look at the data. If I were to kind of draw maybe a little plot, a little graph of what's going on, let's see what's happening. So I'm starting out at 1,000 rabbits, right? And then from there, sorry, my pen has a hard time drawing dots. I don't know why. There we go. Okay, we're off at about 1,000, then what happens? Then it drops down to 750, and then it drops again to 567, then again to 500. Oh, but then it turns back up, 567, 750, 1,000. Oh, now I go even higher. 1,250, 1,433, and then what? 1,500. Oh, but then what? It's going to start dropping. Do you see what's happening here with my data? What's happening? It is dropping, and then what? Then going back up, and then what? Then dropping. And if I kept going, if I kept measuring the rabbits over time, what do you guess is going to happen? It's just going to continue that pattern. It's going to drop, and then increase, and then decrease, and then increase. We call that a periodic function, and we can use sine and cosine in order to talk about this data, in order to represent this data. Let's see what's happening to the foxes. Okay, now if I use a different color here so you can see the difference, the number of foxes. Let's do the same thing. Let's come over here and let's talk about what's happening with these foxes. Okay, starting out at 150, we're going to let that be 150, then what happens? It drops to 143, down to 125, down to 100, down to 75, down to 57, down to 50, and then what? Oh, now we're turned back around to 57, to 75. Sorry, my dots aren't working all of a sudden. Let's see what we can do. But you get the picture. Oh, there we go. Starts heading up, up, up. Am I going to have the same thing happen? If my data kept going, what would you expect to happen? In fact, let's make an educated guess over here. Let's just draw us a new little line here. What if I went out to month 12? What would be your guess for both rabbits and foxes? How many rabbits would you expect in December? At the end of December, the beginning of December, how many would you expect to be? Well, look at the pattern. All right, it went up, 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 and then it started coming back down. After 1,250, I would expect it to go to what? 1,000. And what about the foxes? What's it doing? It's going down, 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 and then starts heading back up, 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 and I would make an educated guess that it would go up to 150. So, part A says, why is it appropriate to model the number of rabbits and foxes as trigonometric functions of time? Well, when we drew our little graphs, what happened? They went up, and then they went down, then they went up, and then they went down. They repeated this pattern, which creates a periodic function. This increasing, decreasing over time creates that pattern. And thanks to the magic of technology, there's your answer for part A that we talked about. Alright, part B, find an appropriate trigonometric function that models the number of rabbits, r of t, as a function of time, t in months. Then graph the function. Okay, we got to take this data. We're looking just at the rabbit population, and we have to write an equation for it. Okay, I've written some things to help us with this part B. So remember, over here are the formulas for sine and cosine. There we have it. Then we're going to use this information. We're going to find A, B, C, and D so we can then plug it into either the sine or the cosine function. So let's talk about how we do that. When we do the first one, amplitude, remember, what does amplitude mean? Or how do we find it? We take the maximum, subtract the minimum, and then divide by 2. So let's go look at our data within the rabbit population. So let's take a look, and what is our maximum up here? Let's take a look, and it appears right here in month 9, 1,500 is going to be the highest my rabbit population gets. What is my minimum? Where's the lowest? Yep, I'm going to say that 500 right there. So how do we find the amplitude A? Well, that's what we're going to do, is we're going to come down here, and we are going to take that 1,500 and subtract the 500, divided by 2, and that is going to make my amplitude be 500. Okay, pretty good. All right, let's move on to B. What is B? Well, B is going to be our horizontal stretch or shrink. And how do we find that? We use that equation where B is equal to 2 pi over T. Okay, well, I can use 2 pi. The question is, what is T? Well, T is going to be our period. So go look up in our population. So let's go back up to the top to our data. Okay, how long does it take in order for this pattern to repeat? How many months, what's my T, what's my time period for my pattern to repeat? Well, let's take a look up here. Let me get a different color. And starting at 1,000, how long do I go before I start to repeat that? Now I see 1,000, but be careful. I went down, 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 I decreased, and then I increased, but then what? I went back up again. So remember my pattern, it went down, 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 then up, 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 and then it starts to come down, and it's not until this point that that pattern is going to repeat. It has to do the full cycle. It has to go down, up, and then come back to where it's going to repeat that pattern. So how many months is it going to take? It's going to take 12 months. So that means my T down here is 12. So to find B, I'm going to take 2 pi, divide it by 12, and I end up with pi 6 is my B value. Okay, notice I didn't go in alphabetical order. I decided to find D next, and there's a reason for that, and I'll explain in a minute. So my midline, my D value, how am I going to find that? Well, we're going to use that amplitude and my maximum minimum. So take a look up here when I was doing these values, okay? Right here, do you see there's my maximum, which was what? 1,500. And my minimum is 500. So that means if I were to draw a little graph over here, and let's say this is 1,000 right here, and this is 500 right here. So my data goes back and forth between, oh, I messed that up. We got to get 1,500. It goes between 1,500 and 500, doesn't it? Okay, because it kind of starts here, and then what's happening to my data? It goes down, comes back up, it goes up to 1,500, and back down. And that's what makes a full cycle. So it is bouncing between 500 and 1,500. And that makes my midline to be what value? It is that 1,000 right there in the middle of my maximum minimum. How else could I find it? Well, if I know my amplitude is the distance from the midline to my maximum or minimum. So this much had to be 500, right? Or this much had to be 500. So I could have taken my maximum or minimum and either add or subtract 500, that amplitude, to find the midline. Here's my midline, the middle of my graph. All right, clean that up a little bit, and D, my midline is going to be at 500. Okay, so I've got my A value, I've got my B value, D, I'm going to figure out C, but I also need to know, am I going to use the sine function or the cosine function? I like to kind of think about those two functions, and in general, the sine function will always start, well, if I can write here, at the midline, okay? Whereas the cosine function will always start at the maximum. Now, if it's been reflected, okay, then it could start out at the minimum. So those are kind of my basic guidelines to figure out, am I doing the sine or the cosine function? That's a good key for me. Now, if I look at my data, now remember, this is where the C comes into play. Well, if my data doesn't start at either the midline or the max or min, then that tells me I'm going to have to shift my graph either to the left or right in order to make that line up the way I need to. So let's go back up to my data up here. I've drawn all over it, but let's take a look here. Maybe I can get a new color. Where does my, we'll try purple. Where does my rabbits start? It starts out at the value 1,000. We'll take a look at what we figure out 1,000 is what? Oh, I screwed up my midline, you guys. I wrote the wrong value there. Oh, that was really bad. The midline is actually at 1,000. I screwed that up, didn't I? Let's replace that here. There we go. I don't want to have to record this all over again, so we'll just fix that. Okay, so now that's going to make a little more sense. Go back to your data up there, and what did we find? That the number of rabbits starts out at 1,000. That is my midline, so which function is going to be the better to use? It's going to be the sine function. So I am going to use the sine function to represent this data. So here we go. We're going to use, what's my function? R of t, right? Okay, what's my a value? My a is 500, so we have 500. Come on, pen, do something for me. 500, okay, sine. All right, what was my b value? B was pi 6, right? X, I didn't have a shift, a horizontal shift, so I don't have a c value. Plus d, which is going to be plus 1,000. Now the only thing left is to make sure, is this a positive a value or a negative a value? Meaning, do I need to take care of a reflection here? Alright, so let's take a look up here. And in general, my basic sine curve, if I were to come over here and show you that basic sine curve over here, sine starts at the midline, yes. So it normally starts at 0, 0, and it always heads up and then down and then back up again. That's your basic sine curve. Go look at your data. Does it go up and then come down? Well, let's go look at rabbits. No, it comes down, right? If I were to graph, come up here and graph my actual data, it starts off at 1,000, then what? It goes down, then comes back up, and then down. So it looks like that. How do I represent that flip, okay, that reflection in my equation? That's right, we are going to need a negative out in front to account for that. All right, our last thing to do is to graph this, so let's draw a graph. Okay, let's see, we are going to need the values of 500, 1,000, and 1,500. All right, where do I begin? What is my starting value? I'm starting off at 1,000, right? And from there, I have a reflection. Oh, let's get our period out here. So how long does it take us to do one complete cycle? It takes 12 months, right? And if we split that into fourths, so half of 12 is 6, half of 6 is 3, and that would make this value 9. Those are going to be kind of my key points for the sine graph. I start out at 1,000. Because of the negative, I'm going to head downward, and it's going to reach its minimum 1/4 of the way through my period. And then it goes back up to the midline. So at 6 months, I'm back up at 1,000. At 9 months, I'm at my maximum up here at 1,500. And then by month 12, I'm back to the midline. And when I connect those, that gives me that awesome graph. All right, let's see if we can take a look at part C. Part C says, okay, find an appropriate trigonometric function that models the number of foxes, f of t, as a function of time, t in months, then graph the function. So we're going to do everything all over again, but with the foxes. Okay, so let's go take a look at our data for foxes. We need to find the a value. That's my starting point. The amplitude, how do we find the amplitude? We go find our maximum, we go find our minimum. So up here in the chart, where's my maximum? Well, my foxes, the highest it gets is 150. What's the minimum? 50. So let's go back down here and I can find the value of A by taking 150 minus 50 divided by 2, and what does that get me? My amplitude is 50. All right, so just get a feel for that. What does that mean? It means my maximum's at 150. All right, so if I were looking at a graph, if I was up here at 150, can we get that 0 on there? Come on. And here's 50. Then my graph is just going to be going up and down between those two numbers, right? Okay, and if the amplitude is 50, that means my midline is 50 below here, below 150, or it's 50 above my minimum 50, which puts my midline right here in the middle at what value? Yeah, at 100. There's a distance of 50. Do you see what that amplitude is saying? It's saying the distance from here to here is 50, or the distance from here to here is 50. That's what it's telling us. Okay, moving on. Let's take a look. We found the amplitude. Okay, our B value. How do we find B? We take 2 pi and we divide it by our period. Okay, how long does it take to do a full cycle within our fox population? Well, go up there and take a look. Oh, I drew a line. Let's get rid of that. Okay, so let's go back up there to our fox population. And what do you see up there? Do you remember how we drew our curve before? What did we do? We took that curve and we said, okay, it starts at 150. It goes down, 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 down. There's my minimum. And then what happens? Then it goes up, 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 up until I hit month 12. And then what do we guess is going to happen? It's going to go down, 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 and then up, 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 up. So in order for it to do one complete cycle, where is that going to be? Well, it takes from month 0 to month 12. That's one complete cycle. So that means my T, my period, is going to be 12, just like in the rabbit population, making my B value pi 6. Okay, D, that's that midline, which we found when we did part A. What was that midline up there? Do you remember that? Take a look up here. It's this value right here. It's that middle value that we found to be 100. It's you can take the maximum and subtract the amplitude, or the minimum, add the amplitude, and my D is 100. All right, remember C, that's going to come hand in hand when we decide which one of these functions to use. So looking at my data, what's my starting value? Well, I'm starting out, go up to the chart, and, oops, I got off the wrong slide. Here we are. Okay, back up to my chart that I've written all over, and let's take a look. Up there, I'm starting out, my first point is at 150. Now, was that 150? Does it start out the maximum or the minimum or the midline? Yes, that 150 is my maximum. So I'm going to be choosing to use what? The cosine over here. So I'm going to use the cosine because it is starting out at the maximum. I don't need to worry about a horizontal shift. So I am not going to have a value of C. I'm not going to shift this at all. All right, so let's write our equation. How does it tell us to write it? As a function f of t. So here we go. F of t equals, what is my A value? 50. Then cosine. We decide we're going to use the cosine function. Okay, what is my B value? Pi 6 of x. We're not going to have a horizontal shift, so we don't have a C value, plus D. D was 100. And we have written our equation. It wants me to graph it, so let's take a look at what this graph looks like. All right. We are shifted up 100. Our amplitude is 50. That means I'm going to go up to 150 and down to 50. My period was 12. Let's split that into 4, 6, and 3, and 9. All right, I started, what was my beginning value? This is cosine, so I'm going to be starting up at 150. And cosine then drops down to the midline, 1/4 the way, then drops down to the minimum at the halfway point, and then goes back up to the midline, and then all the way back up to the maximum. And that is the graph of 50 cosine pi 6x plus 100. All right, guys, we're almost there. Hang in there. Part D. Give a possible explanation of why one function seems to chase the other function. Okay, guys, I want you to take a look at the two graphs that we made. So right here and right here in order to answer this question. Let's take a look at the pattern of what is happening with our rabbits and our foxes. So remember that this one right here is our rabbits and this one is our foxes. So take a look at the pattern. Let's look at just the first 3 months. All right, rabbits appear to be going in down, down, down. Do you see that right there, that section? It's heading down. And what happens with the foxes? They also are heading in a downward direction. They are decreasing. That would be the right word. They are decreasing. So rabbits are decreasing and so are foxes. Is there any relationship to the food that the foxes eat? If the rabbit population decreases, what do you think happens to the fox population? There's not enough food for them to eat. So their numbers are going to go down. Okay? Look at the next 3 months. Okay? The fox population is still heading down because why? Because there weren't enough rabbits to eat. But the rabbit population, it starts to come up. Okay, that's good. The rabbits start to repopulate. The foxes are still struggling because there's still not quite enough food. But then what happens in the next part? As the rabbit population continues to increase, so between months 6 and 9, oh, they're getting to the highest, to their maximum. So then what happens to the fox population? They start heading up. The foxes go, okay, we have enough food to eat. Now our numbers start to grow. And then what happens? As the foxes get more and more, what happens here between months 9 and 12? Oh, too many foxes. What's going to happen to our rabbit? It starts to go down. So the fox and rabbit population almost keep each other in check. As one gets too high, the other will start to decrease, causing that one to start to decrease, making the other one then increase. They almost chase each other in this pattern of increasing and decreasing. Okay, as if by magic, the answer is there. Isn't that awesome? All right, well, that's the end of our rabbit and fox problem. Good luck, guys. I hope you're doing good with your at-home learning and keep up the good work.